Hello all. So in today's class, we will look at what is called a unit step function. And if you are given an equation of the form y double dash plus ay dash plus by equal to some f under the condition y at 0 equal to 0 and y dash of 0 equal to 0. So how to solve for this equation using the technique of convolution. So for this we'll introduce a function called the unit step function. So we will see a principle called principle of superposition for solving equation of this type. So we'll just go through the method. Okay, so this is a problem we are having. So you have the equation y double dash plus ay dash plus by f equal to 0, which is satisfying the conditions y at 0 equal to 0 and y dash of 0 equal to 0. Then the function defined by u of t equal to 0 if t is less than 0 and 1 if t greater than or equal to 0 is called a unit step function. So unit step function u of t is defined as u of t will take the value 0 if t is less than 0 and 1 if t greater than 0. Now let the solution corresponding, so you have a solution y of t corresponding to the function f here on the right side. ഇനി നമ്മുടെ right side u ആണ് വരുന്നതെങ്കിൽ let the corresponding y value be denoted by a of t. So the solution if on the right hand side u ആണ് വരുന്നതെങ്കിൽ let y of t be denoted by a of t. So a of t is called the initial response. So when you have the unit step function, the equation can be put in the form a double dash plus a dash plus ba equal to u. And now take the Laplace transform on both sides. Okay, so when you take the Laplace transform both sides, you will get so L of a double dash varum. Ini y of a of 0 nu parayna 0 aanu and a dash of 0 is also equal to 0. So L of a double dash edukkumbo you will get p square L of a മാത്രമേ വരുള്ളൂ, ബാക്കി രണ്ട് ടേംസ് 0 ആയിരിക്കും. അതുപോലെ സെക്കൻഡ് ടേമിനും a p L of a വരും and for the third term also b L of a. So that will be equal to L of u. ഇനി L of u എന്ന് പറയുന്നത് നമ്മൾ ഇന്റഗ്രൽ എഴുതുമ്പോൾ L of u will be integral Laplace transformന്റെ integral എന്ന് പറയുന്നത് integral 0 to infinity e raised to minus st e raised to minus pt into function. ഫംഗ്ഷന്റെ വാല്യൂ 0 to infinity 1 ആണ്. അപ്പോൾ this integral will be equal to 1 by p. So therefore L of the Laplace transform of the unit step function will be equal to 1 by p. So what we are getting here is L of a equal to 1 by p into 1 by p square plus ap plus b. So let me denote it as 1 by p into 1 by z of p, where z of p is p square plus ap plus b. So when you have unit step function on the right side, so this is what you get as LA. So LA will be 1 by p into z of p. And now let us consider the general form. ഇനി നമ്മൾ general formula എടുക്കുമ്പോൾ again when you take the Laplace transform, so what you are going to get is L of y equal to L of f into z of p. Same way Laplace transform എടുക്കുക. Laplace transform എടുക്കുമ്പോൾ you are going to get L of y into എടുത്ത z of p തന്നെ ആയിരിക്കും വരിക. നമുക്ക് ഇവിടെ വരുന്നത് z of p എന്ന് പറയുന്ന p square plus ap plus b തന്നെയായിരിക്കും നമുക്ക് general equation വരിക. So you will get L of y into z of p. So on the right side you will be having L of f. So L of y will be equal to L of f by z of p. And now if you divide on both sides by p, so what we get is 1 by p into L of y equal to 1 by p z of p into L of f. Now 1 by p into z of p is L of a. So what we are getting, 1 by p L of y equal to L of a into L of f. Once you have the product of Laplace transform, that is the Laplace transform of a convolution. L of a star f എടുക്കുമ്പോഴാണ്, so we will be getting it as L of a into L of f. So here we will get 1 by p L of y equal to L of a into L of f. So therefore by convolution theorem this can be written as L of a star f. So therefore the value of L of y which we are interested in finding, L of y ആണ് നമുക്ക് കണ്ടുപിടിക്കേണ്ടത്. So L of y will be p into L of a star f. So that is p into L of a star f is integral 0 to t a of t minus tau f of tau d tau. Now this will be equal to, now use the property of the Laplace transform. So L of f dash of x എടുക്കുമ്പോൾ L of f dash will be pfp minus f of 0. നമ്മൾ L of y dash ന്റെ ഫോർമുല എടുത്താണ്. So L of f dash will be pfp minus f of 0. Now we have the initial condition that y at 0 is equal to 0. So f of 0 is 0. So we will get pfp equal to L of f dash. Now this is in the form p fp. That means it's a Laplace transform of this function. So pfp. So therefore pfp will be equal to L of f dash. So we will get L of derivative of this function. So that is d by dt of integral 0 to t a of t minus tau f of tau d tau. So therefore taking inverse Laplace transform on both sides, we are going to get y of t equal to d by dt of integral 0 to t a of t minus tau f of tau d tau. So once we find the solution a of the differential equation, അപ്പോൾ a എന്ന് പറയുന്ന solution നമുക്ക് right side unit step function വരുമ്പോൾ കിട്ടുന്ന solution ആണ്. So once you have that solution a, so once we find the solution a of the differential equation with a unit step function as an input, then we can obtain the solution of any other input f by convoluting a with f and then taking the derivative. So therefore find out a. So therefore y of t will be given by taking the derivative of the convolution integral. So therefore y will be equal to d by dt of integral 0 to t a of t minus tau f of tau d tau. So when you take the differentiation, so we will be getting in this form. So differentiation edukka, differentiate cheyumbo, so we will get in the form so y of t equal to integral 0 to t a dash of t minus tau f of tau d tau plus a of 0 into f of 0. A of 0 is equal to 0. So this term is going to be equal to 0. നമുക്ക് ഈ സൊല്യൂഷനെ ഒന്നെങ്കിൽ ഇങ്ങനെ എഴുതാം, അല്ലെങ്കിൽ നമ്മൾ കൺവല്യൂഷന്റെ ഫോർമുല ഇന്റർചേഞ്ച് ചെയ്യുമ്പോൾ you can either obtain in this form. So the required solution is in the form integral 0 to t f dash of t minus sigma a of sigma d tau plus f of 0 into a of t, or you can also write in the form integral 0 to t a of t minus tau f dash of tau d tau plus f of 0 a of t. So ഏത് ഇന്റഗ്രൽ ആണ് യൂസ് ചെയ്യുന്നുള്ളത് നമ്മുടെ ഫംഗ്ഷന്റെ വാല്യൂവിനെ നമുക്ക് ഇന്റഗ്രേറ്റ് ചെയ്യാൻ ഏതാണോ ഈസിയർ അതിനനുസരിച്ച് യൂസ് ചെയ്യാം. ആൻഡ് നൗ we have a of 0 equal to 0. So therefore y of t will reduce to the form integral 0 to t a dash of t minus tau f of tau d tau. So this way of obtaining the solution is called as the principle of superposition. So this is called as the principle of superposition. So this allows us to represent a solution of our differential equation for a general input function in terms of a solution for the step function. So we start with u on the right side. So we will have the function a in that case. So we obtain a from that, then we use that in the general differential equation to find out the required solution. So this principle is called as the principle of superposition. So let us look into the step once again. Okay, so we have started with, okay, so this was the equation in terms of a. So you have on the right side, appo namak L of a nu parayna 1 by p into z of p varum, and then you write the second equation. L of y will be L of f into z of p. So this can be rewritten as 1 by p L of y equal to L of a into L of f. So therefore you will get L of y equal to PL integral 0 to t a of t minus tau f of tau d tau. So we obtain y of t as d by dt of integral 0 to t a of t minus tau f of tau d tau. Now using the differentiation derivative of integral edukumbo, so this is what you are going to obtain as y of t. Now f of 0 is equal to 0, so that gives y of t equal to integral 0 to t a dash of t minus tau f of tau d tau, allengi you have in the form integral 0 to t a of t minus tau f dash of tau d tau. So let us look at problem on the superposition principle. So an example is use the principle of superposition to solve the equation y double dash plus y dash minus 6y equal to 2 e raised to 3t. Now നമ്മൾ എടുക്കുന്ന പ്രോബ്ലത്തിൽ the initial condition will be y at 0 equal to 0 and y dash of 0 equal to 0. So here when you take the Laplace transform, so we are going to get in the form p square plus p minus 6 into L of y equal to, so we start with the equation y double dash plus y dash minus 6y equal to u. Okay, sorry, a varum. Okay, so we start with the equation a double dash plus a dash minus 6a equal to 0. So when you take the Laplace transform, initial condition is 0 ayadonde we will get p square plus p minus 6 into L of a equal to 1 by p. So therefore L of a will be 1 by p into p square plus p minus 6. And now we need to find out a of t. So ഇവിടെ നിന്ന് inverse Laplace transform എടുക്കുമ്പോൾ, so you will get a of t. So a of t will be L inverse of 1 by p square plus p minus 6. So നമുക്ക് partial fractions ആയിട്ട് convert ചെയ്തിട്ട് solution കണ്ടുപിടിക്കാം. So we will get y of t equal to integral 0 to t a dash of t minus tau f of tau d tau plus a of 0 into f of t. ഇനി നമ്മൾ കൺവല്യൂഷൻ എടുക്കുമ്പോൾ നമുക്ക് നേരെ തിരിച്ചു എടുക്കാം. സോ നമുക്ക് L of a into L of f ആണ് വന്നത്. അപ്പൊ ഞാൻ കൺവല്യൂഷൻ ഇന്റഗ്രൽ എഴുതുമ്പോൾ എനിക്ക് എഫിന് t മൈനസ് ടൗ വരുന്ന പോലെയും എഴുതാം. So in that way you will get the result as y of t equal to integral 0 to t f dash of t minus sigma a of sigma d sigma plus f of 0 into a of t. So you are simply replacing a by f. So these are the two different formulas of y of t. അപ്പം നമ്മുടെ കൺവീനിയൻസ് അനുസരിച്ച് നമുക്ക് ചൂസ് ചെയ്യാം. ഏതാണോ ഇന്റഗ്രേറ്റ് ചെയ്യാൻ എളുപ്പം അതിനനുസരിച്ച് നമ്മൾ ഫോർമുല എടുക്കുക. ഓക്കെ, സോ therefore this is the value of y of t. So y of t is obtained as integral 0 to t a of t minus tau f dash of tau d tau plus f of 0 into a of t, and this is how we obtain the solution. So this principle, and again in our initial condition, if a of 0 is equal to 0, then the equation will reduce to this form. Now this principle is called as the principle of superposition. So first we will start with unit step function on the right hand side. We will find the corresponding value a of t. by a of t substitute ചെയ്താണ് നമ്മൾ y of t യുടെ value കണ്ടുപിടിക്കുക. So if you look at this example, okay, so let us look at the example. Use the principle of superposition to solve the equation y double dash plus y dash minus 6y equal to 2 e raised to 3t with the initial condition y at 0 equal to 0 and y dash of 0 equal to 0. Here നമ്മുടെ ഇനീഷ്യൽ കണ്ടീഷൻ എപ്പോഴും y at 0 equal to 0 and y dash of 0 equal to 0 ആയിരിക്കും. അങ്ങനെയുള്ള പ്രോബ്ലത്തിനാണ് നമ്മൾ ഈ ടെക്നിക്ക് യൂസ് ചെയ്ത് സോൾവ് ചെയ്യുക. സോ we will write the equation in this form: a double dash plus a dash minus 6a equal to u, and when you take the Laplace transform you will get L of a as 1 by p into p square plus p minus 6. So when you take the inverse Laplace transform of this, you will obtain a of t. Now once you obtain a of t, നമുക്ക് y യുടെ ഫോർമുല യൂസ് ചെയ്ത് you can find out what is the value of y. So that is the technique of solving the problem using the principle of superposition. So we are seeing the solution of this equation: y double dash plus y dash minus 6y equal to 2 e raised to 3t, y at 0 equal to 0 and y dash of 0 equal to 0. So consider the equation a double dash plus ay dash minus 6a equal to u. So taking Laplace transform we will get p square L of a plus p L of a minus 6 L of a equal to, this will be 1 by p. So that implies L of a will be equal to 1 by p into p square plus p minus 6. So that is 1 by p into, so this is p plus 3 into p minus 2. Now we need to find a of t. So a of t is going to be L inverse of 1 by p into p plus 3 p minus 2. Now 1 by p into p plus 3 p minus 2 can be written as a by p plus b by p plus 3 plus c by p minus 2. So taking partial fraction you will get 1 equal to a p plus 3 into p minus 2 varum plus b p into p minus 2 varum plus c p into p plus 3 വരും. So p equal to 0 implies so a will be minus 1 by 6. Now p equal to 2 implies so p equal to 2 വരുമ്പോൾ you will get c value. C will be equal to so 2 into 5 1 by 10 വരും. And when p equal to minus 3 implies so you will have 1 equal to minus 3b into minus 5. So b will be equal to 1 by 15. So therefore a of t will be L inverse of so a is minus 1 by 6 by p, b is 1 by 15 by p plus 3 and c is 1 by 10 by p minus 2. So that will be equal to minus 1 by 6, then 1 by p plus 3 varanamengil that will be 1 by 15 into e raised to minus 3t varanam, then 1 by 10 e raised to 2t. So that will be the value of a of t. So we have obtained a of t. Now use the formula. ഇനി നമ്മുടെ f of t എന്ന് പറയുന്നത് f of t will be equal to 2 e raised to 3t. So if f of t is 2 e raised to 3t, so f dash of t will be 6 e raised to 3t. So now let us use the formula for y of t. So therefore y of t will be equal to integral 0 to t a of t minus tau f dash of tau d tau plus f of 0 into a of t. So substituting a, you will get integral 0 to t minus 1 by 6 plus 1 by 15 e raised to minus 3 t minus tau plus 1 by 10 e raised to 2 t minus tau into f dash of tau is 6 e raised to 3t. F dash of tau ആണ് അപ്പോൾ 6 e raised to 3 tau. So d tau plus f of 0 is 2 into a of t is minus 1 by 6 plus e raised to minus 3t by 15 plus e raised to 2t by 10. So that will be equal to integral 0 to t minus 1 by 6. Okay, so minus 1 varum minus e raised to 3 tau plus 1 by 15 e raised to minus 3t. 6 by 15 varum 6 by 15 e raised to minus 3t e raised to 6 tau plus 1 by 6 by 10 varum 6 by 10 e raised to 2t e raised to tau d tau plus minus 1 by 3 plus 2 by 15 e raised to minus 3t plus e raised to 2t by 5 varum. So upon integrating you will get minus e raised to 3 tau by 3, then 6 by 15 e raised to minus 3t e raised to 6 tau by 6 varum plus this is 3 by 5 e raised to 2t e raised to tau varum from 0 to t, then minus 1 by 3 plus 2 by 15 e raised to minus 3t plus e raised to 2t by 5. So upon simplifying you are going to get it as 1 by 3 e raised to 3t plus e raised to minus 3t by 15 minus 2 by 5 e raised to 2t. So please do the intermediate steps. So therefore we are going to get y of t as e raised to 3t by 3 plus e raised to minus 3t by 15 minus 2 by 5 e raised to 2t. So therefore we started with the equation on the right side. We have started with the function u. So the corresponding y value a added. So we have found what is a of t. So we have obtained a of t. Once we have obtained a of t, so y of t will be given by integral 0 to t a of t minus tau f dash of tau d tau plus f of 0 into a of t. So that is how we use the unit step function to find out the integral.